Welcome to the first lesson of Chapter 5. We have least common multiples. Our objective is we will find the least common multiple of numbers by using listing and the prime factorization. So, what is a multiple? A multiple is the product of a number, that number, and a whole number, not zero. So, for example, if we started with the multiples of 6. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And so on. Remember, multiple, I like to say massive multiple. It should be bigger than the number or the same. The least common multiple is the smallest number shared by two numbers. It's always larger or equal to either number. So let's find the least common multiple of these by listing the multiples. Remember, it's easier to start with the bigger number if you're listing. So let's start with 3 and 4. So first multiple of 4 is 4, 3 doesn't go into 4. Next multiple is 8, 3 doesn't go into 8. Next multiple 12, 3 does go into 12, so 12 would be the least common multiple. Notice that 3 and 4 don't have any common factors, so you could just multiply 3 times 4 to be 12. Now let's take 15 and 10. We'll start by listing the multiples of 15, the bigger number. 15 times 1 is 15. 15 times 2 is 30. And we notice 10 goes into 30. That's the least common multiple. Notice that 15 and 10 had 5 in common, so you can't just multiply them together. Now we're going to find the least common multiple using the prime factorization. So we're going to break up 12. And we're going to break up 40. And the way that I like to think of this is we need to use every part of both numbers, but not overlapping at all. So we're going to make a nice little chart. Okay, what do they have in common so far? They both have a 2, so we're going to write a 2 right there. They also both have a second 2. There's nothing else that they have in common, so now we just need to fill in that the 12 has a 3, 40 doesn't, so you leave it blank. 40 has another 2, and 40 has another 5. So 40 is 2, 2, 2, 5, and 12 is 2, 2, and 3. Now, all we need to do is take what's in each column. 2 times 2 times 3 times 2 times 5. Notice that when there was overlap, I only took 1. So 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. And then we have to do 24 times 5. So the least common multiple of 12 and 40 is 120. It includes every part of both numbers, but only counts the overlapping numbers once. Let's find the least common multiple of 6 and 16 this way, just to practice one more time. Remember that you can always go back and watch this again, pause it, rewind. Really good idea. Okay, so now we're going to make our chart. We know they have a 2 in common. Cross out the 2 when we use it. Now there's nothing else they have in common, so the 6 has a 3, and then the 16 has 3 more 2's. So we're going to end up getting 2 times 3 times 2 times 2 times 2. So an easy way to start is we know that the 4 2's are all going to multiply to be 16. So really it's just 16 times 3. So our least common multiple would be 48. Now, when we have 3 numbers, you can do listing or do the prime factorization. So if we were to list, let's start with the biggest number. So first multiple is 12. They don't go into 12. Then 24. They don't go into 24. Then 36. They don't go into 36. Then 48, they don't go into 48. Then 60, they do both go into 60. If we were to do the prime factorization, we'd have to break it down. 10 is 2 and 5. 12 is 3 and 4. 2 and 2. So we could show what they all have in common. Now there's nothing that they all 3 have in common, but the 10 and the 12 have a 2, and then the 5 and the 10 both have a 5. And then the 12 has an extra 2 and an extra 3. So if we multiplied 2 times 5 times 2 times 3, we would also get 60. Now remember, this chapter is everything you've learned, but adding variables to it. So if we have 6a squared and 20a cubed, we have to make sure to include all of both numbers. So we have 2 and 3. So now let's create our chart. So 6 and 20 have the 2 in common. Then the 6 has a 3. The 20 has another 2. And the 20 has the 5. Now we have to think about the variables. Both variables have a squared, but the 20 has an extra a, so we need to include that. So we'll write a cubed on the bottom. In this case, we need to take the highest variable, so we have 2 times 3 times 2 times 5 times a cubed. This is so that it includes all of 6a squared and all of 20a squared. 2 times 3 is 6, 6 times 2 is 12, 12 times 5, 60a cubed. Now on your own, pause the video and try this one. Think about what variables you would have to include. Remember, you'd have to include all of a squared and all of c. So those would be your variables, and then you would find the least common multiple of 18 and 12. Here's a really important big idea. With the variables, you want to take the highest power of each variable. So for example, if we were finding the least common multiple of these three numbers, we would be taking x cubed, because it would include x squared and x, and we would be taking y to the 7th. It includes y and y squared and y to the 7th. So last, least common multiple is usually used in word problems when we're talking about when things will happen at the same time, if they happen every 4 days, every 6 days. So for example, Mrs. Zarn likes to practice juggling and water aerobics. On Friday, they happened on the same day. She juggles every 4 days and she does water aerobics every 6 days. And how many days will the two activities happen on the same day again? So we have to think about 4 and 6. What's our least common multiple? Okay, 4 doesn't go into 6, but 4 does go into 12. So in 12 days, they'll occur on the same day again, because 12 is a multiple of both. So we can count from Friday, 12 days from there. Friday to Friday is 7, and then 8, 9, 10, 11, 12. 5 more days from Friday: Saturday, Sunday, Monday, Tuesday, Wednesday. Here's your exit paths. Go ahead and try out a least common multiple without variables and with variables.